Hi everyone, this is Susan Listberger, and my systems thinking project is around potable water on a cruise ship. So thanks for your attention. The question or the problem that I wanted to solve or figure out was how to get potable water on a cruise ship and then ultimately also get rid of that waste. So the reason I chose this is because this past week I was cruising on the Disney Dream. That's a picture of me on the left-hand side there. I'm the one in the hat with a couple of friends, and we went cruising on the Disney Dream. That was a May celebration. And then on the right-hand side there you can see that is, I can assure you, a water-based beverage. And I enjoyed many of those while on the cruise. And so I wanted to know just how did they get the potable water on the cruise? And then how did they get rid of it? How did they get rid of the waste, and what does that system look like? So that's the motivation behind investigating this problem. And most of the information that I have came directly from the assistant cruise director, a woman named Pau. She gave us a tour, and it was mostly focusing on the theming behind the Disney Dream, but we also asked her a couple of specific questions about the water so that we could get some of this information and then I could share it with you. So without further ado, I'm going to walk through the stocks in this situation. So I identified three main stocks. There are a few more in this system, but these are the ones that I really wanted to focus on at the beginning. This is where I started my process. So first off is the ocean, and certainly that's a stock of water. It's one I think that everybody would identify on planet Earth here, but it's not necessarily where I thought the water on the cruise ship came from. So that was interesting for me, and I showed it as a cloud because really the ocean is the biggest stock we have, I think. The next one is a potable water tank, and this is a tank that's actually on board the ship that contains drinkable water. And then the next is the wastewater tank, or the waste tank. And so that's another tank that's on the ship that contains wastewater. So then next up it gets a little bit more complicated, but I'll walk through just briefly how I put this together. So on a cruise ship, water is pumped out of the ocean, so that's my stock at the very beginning, and then the flow goes to a reverse osmosis water tank. So reverse osmosis, that's actually the valve, that process. It controls how much water gets into the reverse osmosis or the revo tank. And so that's a filtration process that removes the salt. It removes a lot of other harmful components, bacteria, those kind of things from the seawater. And it gets stored into the reverse osmosis water tank. I also included another stock. This is the mineral stock. So minerals are then added back to that reverse osmosis water. So there's another flow that goes from the mineral stock into the reverse osmosis water tank, and that's controlled by an addition rate valve. And the minerals are added not only to make the water a little bit healthier, but really it's about taste. So the minerals are added back so that the water has a better taste, a more pleasant taste to the people on the ship. So once the mineral is added to the reverse osmosis water tank, then we are effectively converting that water to potable drinking water. So then that potable drinking water is stored in another potable water tank, which is controlled by the conversion rate here of adding the minerals and then the reverse osmosis water. Next up then, we have the rate of consumption valve. So this is really the flow from potable water into human beings, right? So it's people consuming that water, drinking that water. So whether it's coming from their tap, whether it's coming in a pink glass with an umbrella on top, it's how much people are consuming. And then ultimately that water passes through your body. You use the nutrients, or you just use up the water, and then it's removed as waste, and so it goes into the wastewater tank. And I don't think I need to explain how that process works, but really ultimately what we're talking about is toilet flushes. So that wastewater is then stored in a tank. And I wanted to add this additional flow down here. So there's an additional flow out of that potable water, so people are drinking water. And then there's another rate control, which is around perspiration and evaporation. So whether or not the water is evaporating off the deck of the ship, if it's evaporating off of your skin because you're perspiring, if it's evaporating out of your drink cup or out of the pool, many of those different places, that water then is ultimately returned to the atmosphere. So that, again, there could be an additional line that goes from the atmosphere here back into the ocean. I think a lot of people already understand the water cycle and how it works on a global basis, so I didn't focus so much on that. I really wanted to think about the cruise ship. And then next, I get into a little bit here. This is the gross part, so bear with me. But really then what happens is that wastewater that's stored in a wastewater tank, that is treated. So it's treated not only to remove microbes, bacteria, it's pulverized, crushed, and treated so that then it can be disposed of. And in some cases that means it just goes into a treated waste tank. In other cases that means that it after it's been processed and it's been certified and approved, then the flow goes back out into the ocean, and so then that waste is returned back to the ocean. So I know that sounds a little bit like a disgusting process, but it's really no different than what would happen, farmers putting manure on their crops or on their farmland. So really we're returning those nutrients back into the ocean so that they can fertilize seaweed, plant life, marine life, all of those things. So it's sort of the circle of life here, folks, even though it seems a little bit gross. But on the next slide, I'll get to some of the controls that are in place. So the first one up top here we have is weather. And so this really is a converter, so the weather influences not only the rate of consumption. So when it's hotter, people are going to be drinking more water. When it's colder, people don't drink as much. They also, when it's colder, people don't perspire as much. And the inverse is true. When it's hotter, people perspire more. So that's one of the controls that happens in this system. The other is around water quality testing. So I have sort of two converters here. So the first one is information that's coming out of the potable water tank. So there's a series of water quality testing that's regulated that needs to be met in order to have that water be certified as potable, as drinkable. So the water is taken from the tank and it's tested so that then we have feedback to know whether or not we need to change any part of the process. So whether or not we need to add additional minerals, or maybe we need to drop back on that rate, or if we need to do something with our reverse osmosis process. Perhaps we need to change filters, maybe we need to filter slower or more quickly. So it's all of those things that will give us feedback in this system. And then last but not least, I added one more, and so this really is the governmental regulations. So this hopefully will make you feel a little bit better about this big arrow on the top here. So the EPA is responsible for governing how waste and also water can be treated on cruise ships. So the nicer part of this, the government regulates the water quality. So there are stringent testing that has to be completed before that water is certified as potable and drinkable for humans. So that's one piece, one converter that happens. And then the governmental regulations also control that waste and where it can be released, how much can be released, and what exactly needs to happen to it before it can be released. So there's, again, a series of testing that needs to happen to make sure that that microbe counts are down, and that really what we are talking about here is fertilizer and not waste. So that's, again, additional information that needs to be passed back from the government to the wastewater tank so that it can be treated. So that's kind of the big picture. That's how this works. That's how potable water is not only made, but then also disposed of on a cruise ship. I think there are a few other things that I could talk about, but I wanted to stick pretty close to the actual system of water on the ship. But, certainly additional regulation that could significantly impact the system. So if we have more government regulation or less, that could change not only the environmental impacts, but it could also change the economical feasibility of doing these things on a cruise ship. And to tag onto that, the economy. So that's another good input that could be added, another element that could be added to this flow. And that really is that the better the economy is doing, the more people have disposable income to spend on vacations and cruises. And so that might affect this flow, this system. If there are more people on the cruise, there would be more consumption of water. Also, if there are more cruise ships in the ocean, that might affect how much of that waste can be disposed of, or the